In today's session, we are going to discuss the end term revision using previous term question papers.
Okay, ma'am. So we will solve like question
Yeah.
paper of
Yeah.
previous and term.
Yeah.
Okay, ma'am.
So this is the September 2024 forenoon question paper. Last year September question paper. Is my screen visible?
Yes,
Yes,
ma'am.
ma'am.
Yeah. So see them. Which of the following data types will result the largest memory allocation? So, so these are the options given to you: int, char, double, float. So you know that integer will occupy either 2 or 4 bytes based on the processor. So let us consider it occupies 4 bytes. So character will occupy 1 byte of memory, whereas a double will occupy 8 bytes. Float will occupy 4 bytes. Okay. So which data type is the largest memory will be allocated? So
Double.
to the double data type.
Yeah, ma'am, but float has 8. No?
Yeah, float is a 4 bytes. Double is a 2 times more than the float.
Okay.
Double means twice the float.
Okay.
Next, what is the primary difference between a function declaration and a function definition in C? So function declaration means we will say to your compiler that there is one function with this name. It will take this type of parameters and it will return this type of data. So only that. Okay. Whereas function definition will implement that what. So how you are from the given input, how you are calculating your output and returning. So that implementation part will be there in the definition. Okay. So a function declaration specifies the name of the function, return type, and parameters of the function, while the function definition provides the implementation of the function. Okay. So this is the correct option. Okay. Whereas the second option gave opposite. Declaration means implementation, definition means signature. So this is just opposite. Declaration means a function signature. Definition means implementation. Okay. So both are same. No, not same. So function declarations are only required for recursive functions. No, it is required for all the functions, except the functions which returns an integer value. For all other type of functions, we need to write a declaration of the function. Okay. So the correct option is function declaration specifies the name, return type. That is nothing but the signature of the function. Whereas function definition will provide the implementation of the function. The next question. Which of the following is not a valid memory segment in C? So there are mainly 4 types of memory segments. We'll have the code segment, stack segment, data segment, and a heap segment, or we also call that as a extra segment. Okay. So code segment means that part of the memory is used to save your program. When you save your program, you require some memory. So that memory, it will take it from the code segment, the memory required to store your program. Program is nothing but a code. Okay. Whereas in your program, you'll have so many variables. So for each variable, we need to allocate the memory to store the data. So like variables are nothing but they will carry the data of your program. So the memory required for those variables will be taken from data segment. Okay. Whereas suppose when you have a function calls, so many recursive function calls or the normal function calls, so your control will transfer from main function definition to the subfunction definition by storing the local variables and their return address, all those into a stack, and then it will jump to the subprogram, and it will execute the subprogram and return back by popping the local status and then return back to the main function. So while it is leaving from one block to the another block, it will store all the local variable status in a one memory that is called stack memory. Okay, so there it will take the memory required to store that status. It will take it from stack segment. Okay, whereas generally these segments, code segments, data segment, and stack segment, in general, they will have only like limited in size. So if you have a so much big program where the code is not sufficient, code segment is not sufficient, or your data segment is not sufficient to declare your variables, or you have a recursive call that to store the local status, the stack is not enough. Okay, so in such a cases, we take the memory from extra segment, so extra segment or a heap segment, or so all these three segment, code segment, heap segment, data segment, will be allocated by your system automatically. These memories will be allocated by your system automatically. Whereas, so those are the static memories. When you want to allocate, the user want to allocate the memory dynamically to your variable or to your program or something, then in that case, he has to access the memory from heap segment. So that is possible only using pointers. Okay. So among these, so code segment is a memory segment of C. Heap segment is also a memory segment of a C. Data segment is also a memory segment. But register segment, there is no register segment. Okay. Whereas you have a stack segment. So this is the odd one. So, okay, it is not a valid memory segment in C, register segment. Next question. What will be the output of the following code? So we have declared two variables, x value as 2, y value as 5. And Z is calculated using unary operators, increment and decrement operators, plus plus and minus minus. So this is a post increment. This x value is a post increment. That means first it will substitute the x value in the expression, and then it gets incremented. So 2
Increment
will,
by 1. Yes.
yeah. So 2 will be substituted there and x will become 3. So here in the expression, the substitution value will be only 2. So 2 plus, this is a pre-decrement. Pre-decrement means first y value will be decremented and that decremented value will be substituted in the expression. Yeah. So 5, y value is 5. When you decrement it, it will become 4. Yeah. 4 is substituted in the expression. So 2 plus 4. 2 plus 4 will be 6. So 6. The Z value will be 6. So
Ma'am, and we increment also, ma'am. So 7, na?
No.
Because we increment in the 2.
No.
So it become a 3.
Yeah. While calculating, x value will be 3. But while calculating this expression, first x before incremented value, if it is a post operator, post increment or post decrement, First,
Okay.
its value will be substituted. After only it will be incremented or decremented. That means before operation is performed, that value will be substituted in case of post. Whereas after increment, decrement value will be substituted in case of pre. So this is a pre-decremented. So it is decremented. Decremented value is substituted here.
Okay.
Whereas this is a post. So first value will be substituted here. After that, it gets incremented. So X and Y values will become 3 and 4 after this expression. But in the expression, X value is substituted as 2. Y value is substituted as 4.
4.
So let us execute and see. So this is your code. X equal to 2, Y equal to 5, and then calculated. So let us run this. So the value that you are found here is 6.
Okay. So ma'am, what will be happen with that post increment?
See here, how it will work is Z equal to, first it will substitute X value as 2. Before incremented value will be substituted in case of post operator, post increment or post
Yes, yes.
increment. So before performing this operation, what is the X value? 2.
2.
So it will substitute that plus, this is a, Y is a pre-decrement. Pre means first it will decrement, that decremented value will be substituted. So when you decrement the Y value, so it will be 4.
4.
So 4 will be substituted here. So what will be the Z? 2 plus 4. So it will be 6. So you are displaying the Z value here. Okay, you are displaying the Z value here. So it will display 6. But if you display the X and Y values, so let me even display X is equal to %D, Y is equal to %D. Okay, let me display the X and Y values also. Okay. So if I run this, so the Z value is 6, X value is 3 because X is incremented. Because X is incremented here, so X will become 1 more. So 2 plus 1 will be 3.
So ma'am, post increment things are used for loops only, right? Because
No.
in loops, we see that if we want to increment one value till 10, so we will write a post.
Not like that. Not like that. Okay, you can use increment operator either before or after the operand. But the difference where you, so if you didn't use it in an expression, both are same. Both are same. Increment, pre-increment or post-increment, both will be increment the operand by 1 unit. But when you use that in an expression, so whether it will take the value before performing the operation or after performing the operation, that matters. Okay. If it is a pre-operator, pre-increment or pre-decrement operator, first it will substitute after the operation is performed. It will substitute the value after the operation is performed. Suppose if it is a post decrement or post increment, so it will substitute the value before it performs the operation. That is the difference. Okay. So because this is a post, so before performing the operation, what the X is having, that value is substituted here.
Okay.
So
ma'am,
before
where will we get the post value?
immediately. So
Yeah.
x plus plus means x will get affected with the increment by one value.
Okay.
So okay, here the x will be incremented by 1, but in this
It will
expression it
happen
will
after.
substitute
Yeah.
before incremented value.
So it will be happen, but after performing the operation, like we
Yeah,
given the.
first it will substitute here, after that it gets incremented.
Okay.
Here also first it decrements and then substitutes.
Okay, ma'am.
That is the difference.
Yeah.
So the Z value, we are asked to display only the Z value. So the Z value will be
6.
6. So it will be 6. Okay. So 6 is the answer. Next question. Consider the following code, which is intended to find the largest of 3 input numbers. However, it contains a logical error. So this code is written to find the largest of 3 numbers, but there is some mistake in this code. Okay, some logical error in this code.
Okay, like we use.
Can anyone guess what is that logical error? What is the error in this program to find the largest of 3 numbers, where A, B, C are those 3 numbers? So what mistake the program contains?
Ma'am, in the if statement, if A is greater than B or A, ma'am, there should be and.
Yeah.
Like if
So when you can say A is the largest, when it is more than B, and also when it is more than C. When both conditions are true, then only we can say that A is big. So both the conditions are to be satisfied. To say that, we combine those two conditions with and, not or. Okay. Suppose if you want to say any one of the condition must be true to become the whole expression to be true, in that case we combine the expression with R. But here, to say that A is big, you should ensure that A must be greater than B as well as greater than C. Then only you can say A is big. Okay. So here the mistake is, here you should have under. So but we have R. Okay. So now for which input will the code print incorrect output? So because there is some logical error here, so it will not work for all the given inputs. So some input will be failed. So here there are 4 cases given to you. So for which input this program will fail to display the largest value? That is the question. Okay. So first input you take A. Suppose if see, A greater than B, 5 greater than 3. So first condition is true. So it won't check the second condition at all, and then it will display A is big. So this will give you correct answer only because A is the biggest. Next, for the second case, it will check A greater than B, which is false. Then it will check A greater than C. That is also false. So both are false. So this if condition fails, so it will come to this particular if condition. So here B greater than C, it is true. So it will display the B value. So B here also for this particular case, B is the largest. So it is giving the correct answer. Then third case, A value is 2, B value is 2. A greater than B will fail. And also A greater than C is also fails because 2 greater than 3 is wrong. So in that case also it will come to B greater than C case. Here B greater than C is false. So it will display C is the biggest. So for this case C is the biggest. So this will also give you the correct answer. Whereas for the last case, A value is 3, 3 greater than 2. So 3 greater than 2, first condition is true. It won't check the second condition when you combine the conditions using R. So it will directly print A is the big, but A is not the big, C is the big. So this, for this particular case, this program will give you the false answer or incorrect answer. Okay. So for the last case, it will give you the incorrect answer. Okay. So so if you combine this with and, when this fails, it will check this condition also. Or when this fails, the whole expression will be failed, and then it will come to this case. And then it will check among B and C. So it will find that C is the big. Okay. So the mistake here. So for that mistake, which input is giving the incorrect answer is the last case. Last case, it will print A value as the biggest, but A is not the biggest here. Okay, so that code also let us execute it. So this is your code. So run it. And here you give the inputs 532. First case is 532. 532. So it gave 5. So correct answer. Whereas second case 143. 143. So it is giving 4. So 4 is correct answer. Whereas 223, next case, again run 223. So 3 is the largest. So that is also giving the correct answer. Whereas for the last case, 324. Run it. 324. So actual output is 4, but it is giving 3. So for the last case, it is giving the wrong result. Next. Consider the below C program, which takes positive integer as input. What is the purpose of recursive function? Okay. So for what purpose we have written this function? That you need to find out. So here we have written a recursive function, so which is calling itself. So a function is called recursive when it calls itself. So recursive fun is calling recursive fun. So it is a recursive function. So suppose, so what it is doing, if n value is 0, it is returning 0. That means the base case here is n value becomes 0. So when n value is 0, it will stop. It will stop calling itself. Okay. Otherwise, it is checking whether n is a even number or not, even or odd. So n mod 2 not equal to 0 means n value is odd. If n value is odd, what it is doing? Again, it is calling a recursive function with n value as n minus 1. Otherwise, it is returning 1 plus. Again, it is calling the recursive function with n value as n minus 1. So what happens here? When it is even, every time it is adding 1. That means it is counting how many even numbers are there up to n. From 0 to n, so when it is 0, it is stopping. So from 1 to n, how many even numbers are there? That it is counting here. Okay. So when it is odd, just it is simply calling the recursive function. It is not doing anything. Whereas when it is even, it is adding a count 1 for every call. So at the end, when n becomes 0, so it will return how many even numbers are there in the range 1 to n. So count the number of odd numbers. No, it is not counting odd numbers. When it is odd, it is simply calling the recursion. It is not counting. Whereas count the number of even numbers from 1 to n. Yes. So when it is even, it is adding 1 to the recursive call. So 1 plus like that. When how many times the even number comes, those many number of times that recursive call will occur. See how it gets executed. So recursive function of say 5 or say 10. So first it is 10 means even number. So it will be called as 1 plus recursive function of 9. N value will be passed as n minus 1. Okay. So again, so it will be called as, because it is n value is odd, so it will call recursive function of 8. N value is n minus 1. So again it is even. So when it is even, so it will be called as 1 plus recursive function of 7. Okay. So when it is odd, it will be called as recursive function of 6. Okay. So again 1 plus recursive function of 5. Okay. So four, taken a somewhat bigger number. Okay. So let me take 6 or 7. 8. So this will be 7. This will be 6. This will be 5. This will be 4. This will be 3. This will be 2. One plus, because a function of 1. So it is an odd, it will call it as recursive function of 0. So when it will call with n value as 0, so this will return 0 to this place. Okay, because the base case given here is so base case when n equal to 0, return 0. So that is your base case. Okay, so it will return 0 to this place. That 0 will be returned to here. Okay, so 1 plus 0, it will return 1 to this place. And from here again, the same 1 will be passed to here. So this is replaced by 1. So 1 plus 1, it will return 2. Here, this same 2 will be passed to here, this place. So 1 plus 2, it will return 3. 3 to this place. The same 3 will be returned to this place. So 1 plus 3, 4. So the 4 is returned to the main calling place. So to this place, it will return 4. So that means between 1 and 8, there are 4 even numbers. That is 2, 4, 6, and 8. Okay. So like that, it will count the number of even numbers between 1 and n. Okay. So let us execute that code. So this is the code. Just run it. So if it is 8, there are 4 even numbers. Suppose 9. So 1 to 9 also, there are only 4 even numbers. Okay. So like that. So the code will return how many even numbers are there between 1 and n. So count the number of even numbers from 1 to n. So this option is correct. So the next question, which of the following is correct way to allocate memory dynamically for a 2D array with m rows and n columns in C? So when you want to do a dynamic memory allocation, first we need to create m pointers where m is the number of rows. We need to create m pointers. In each pointer, we need to store n values, where n is the number of columns. So in each row, for each row, we will create one pointer. So in that pointer is pointing to n different values, a single dimensional array. Okay. So m single dimensional arrays of size n will be created. Okay. So if your size is m rows and n columns. So what we need to do? We need to create m pointers. How many rows are there? Those many number of pointers. Each pointer is pointing to n different values. Okay. So every row is considered like a one pointer array. Okay. So first we need to allocate. So a pointer, how many pointers we need to create? M pointers. Memory allocated for single integer. Generally, pointer means it will have an address. So always the address is an integer address. So size of integer into m. So we need to create m pointers. So for each pointer, we need to allocate size, one pointer size into m, so that m pointers memory will be allocated. So this is called a pointer to a pointer. 2D array, one dimensional array means a pointer. One single pointer will be pointing to one dimensional array. So pointers to pointer, that means if it is a 2D array using pointer, you'll have 2 stars. Suppose if it is a 3D array, you'll have a 3 stars. Okay. So like that, for each dimension, you will have 1 star. So this is a 2-dimensional array. So star star array equal to, so that means here you need to create m pointers. So first we need to allocate the memory to store those m pointers. So in that, for at each pointer, again, we need to allocate the memory to store n columns, n values. So some n integer values. So here we are allocating the memory to store n integer values, and that memory will be stored at array of I, where I value is varying from 0 to m. So total m pointers. For each pointer, we are allocating the memory. For each pointer, how much memory we are allocating? Where you can store n integers. Okay. So at each pointer, you are creating a single dimensional array. In that single dimensional array, you can able to store n values. So this is the correct code. This is the correct code. So here it is allocating a single block, like a single block of size m by n. But 2D array means how we will. So this is like it is created like a single dimensional array, continuous. Okay. Whereas we need to able to distinguish the first row from the second row. So if you want to distinguish the first row value from the second row, then we need to create n pointers. So like this, for each pointer is one row pointing to one particular row. So here it is declared like even though it is, so it is like a single dimensional array only. So it will create a memory where you can store m into n values. So this is, it will create a memory for storing single dimensional array. Okay. So here also, it has just created in a reverse order. This will create an n by m matrix. This will create an n by m matrix, not m by n matrix. But here we are given that there are m rows and n columns. But here this is the code for n rows and m columns. So which is just the opposite of what we require. So that's why this option is wrong. Whereas the second option is correct. First, we need to allocate m pointers, where m is the number of rows. In each pointer, we need to store n different values. N is the number of columns. Okay. Next. So consider the below code. What will be the output of the above program? So x value is taken as 6, y value is 4. Okay. So here we are performing OR operation, bitwise OR. This is bitwise OR operation between x and y. And here we are calculating the ones complement of y. This ones complement of y and this XOR y is again perform bitwise AND operation between them. Okay. So that value, whatever you are getting, that you are storing in the result and you are displaying the result value. So what is the x value? So this R and AND are the bitwise R, and so all the operators that we have used here are the bitwise operators. That means they will work on each bit of that value. So that means you have to represent that value in the binary form, so that you will get the each bit of it. Okay. So 6 means, what is 6? 0 1 1 0. 6 means, see this.
Yeah. 0 1 1 0.
Yeah, x value is 6. So that means x value is 6. So 0 1 1 0. So I have taken only 4 bits. Generally, it will take 32 bits means. So the remaining zeros will be on the left hand side. So whether you mention it or not, that doesn't affect the result. Okay. So y value is 4. 4 means 0 1 0 0.
Yes.
0 1 0 0. Now, first you perform the bitwise OR operation between these two. So OR means any one of the input must be 1 to get 1, otherwise 0. So first are 0 0 0 or 0 is 0, 1 or 0 is 1, 1 or 1 is 1, 0 or 0 is 0.
0.
So this is the OR operation, like bitwise OR operation. Now we need to find the ones complement of y. Ones complement of y means, so this is your y value. Zeros will become 1, ones will become zeros.
0. Yes.
So, 0 means 1, 1 means 0. So, both zeros you will get 1. So, this is the, for only these bits I have taken, that doesn't affect. I told you, that doesn't affect the remaining bits. So, all the remaining bits are 1 in this case. Okay.
Yeah.
Now, if you are performing AND operation between these two results, so because for this case all the remaining are zeros, for this case all the remaining are ones. When you perform AND operation between the ones and zeros, you will get 0 only. So the result, left hand side of this result is always 0. Okay.
Ma'am,
So-
that tilde used for what?
Ones complement.
Okay.
Ma'am, after that arrow, why there is 2?
Yeah, this value is 2. This decimal equivalent of this is 2.
Okay, ma'am.
The result is 2. To say that I have written like that.
Yeah, and ma'am, what is the XOR?
Not XOR. This is AND operation.
Yeah, this is AND, but you say now XOR. So in XOR, what will be happen?
I didn't said XOR. This is ones complement. Ones complement means ones will become zeros, zeros will become 1.
No, I want to ask that if
Yeah.
here
If
we
it
have
is
to
an XOR,
perform.
what happens?
Yeah.
Suppose when both the bits are different, it will be 1. When both bits are same, it will be 0.
Okay.
Okay. So here it is an AND operation. So AND operation will be 1 only when both the inputs are 1.
1.
So
Yes.
here only for this particular case, both inputs are 1. For all the other case, at least 1 0 is there. So the result is 0 0 1 0. AND operation. AND operation between these two. Okay.
Yeah, ma'am.
So 1 0 means it is nothing but 2. So your answer is, so you convert this into decimal. 1 0 means 2.
2.
So your output will be, so your result will be 2.
2.
Okay. So this is the result. 2. Okay. So let us execute and see. So the output is 2. Okay. You got the answer as 2. Okay. Next, consider the below C code. So here we have used a hash define function. Hash define. So like this is like a macro. It will be like a macro. So the name of the macro is a square. So it is taking one parameter, the x value, and it is returning x star x. So this is the we have defined the macro square, like whatever parameter you are passing, it will return the square of that. Okay.
Yeah. So macro means, ma'am, the things like we are using the header files like that.
No, no, no.
We
Like
define
the
something.
difference I'll tell you. If it is a function, your control will transfer to the definition of the function, execute all the code over there, and then again return back to the calling place. Whereas
Okay.
if it is a macro, whenever you call that, the code which we have used to define the macro is substituted in the calling place. Your control will not transfer. So whenever you call that macro code is substituted in the calling place. It won't, control will not transfer.
Okay.
Overburden will not be there. Okay, that is
It
the
is just like a
difference.
formula. In there we had to put the
You are
value.
substituting.
Yeah.
In the formula, you are substituting the values. So
Values,
like
yeah,
that,
and
it will work.
performing the operation.
Yeah.
Like it will not return anything. It's just like we will put it in the main
Yeah.
program.
It won't.
Yeah.
It won't return anything. Your control will not go. But whenever you call it, the code which we have written in the definition, that code is substituted in that place.
Yeah. And we will
Okay.
get the answer of the after the substituting the values.
Yeah, after simplifying that, we will get the answer.
Okay.
Okay. So here a value is taken as 5, and we have called the square function with a plus 1 as the input. So that means instead of x, we have used a plus 1. So a value is 5. So how it will be called? See here. How it will be called? A value is 5. So wherever there is an x, so here it will substitute like this, x into x. So what is x value? X value is 5 plus 1 into 5 plus 1. It won't simplify. It simply substitute whatever you have given. The same expression, it will substitute in place of x. Okay. So here this is replaced by x into x. What is the x value? X value is nothing but a plus 1. So
Yeah.
a plus 1 star a plus 1. A value
So
is 5.
6
Okay.
into 6.
So
We
like it will not be 6 into 6. See how it will get simplified is star is having highest precedence than plus. In this expression, we have a two different operators. 3 operators are there, where both the operators are plus, another operator is a star. So
okay,
how
like
we
we
are
just multiply
yeah,
1 and 5
Bodmer's
and
rule,
then add all the
something.
values.
So first multiplication has the highest precedence. So first it will do the multiplication operation.
Yes.
So this expression will become now 5 plus 1. After doing the multiplication operation, it will become like this.
Okay.
Now, both operators we have in the expression are having same precedence. Then it will look for associativity. Associativity of arithmetic operator, because
So it
plus
will
is an
start from
arithmetic operator.
left to right.
Yeah, for arithmetic operators, associativity will be left to right. So
Yes.
first, which left operator will be evaluated first? So it will evaluate the expression from left to right. So whichever operator comes on the left hand side, first it will evaluate that. So this will become 5 plus 5. So this will be 10 plus 1. So 10 plus 1 will become 11. So it will evaluate one by one operator. It will simplify one by one operator. So first
Yes.
it will do the star
Multiplication.
multiplication, then left plus, and then right plus.
Right plus, yes.
Okay. So it
Yes.
will be 11.
11.
So the output will be 11. You can execute and see. Suppose if it is a function, what will be the output? Okay. So if I run this, so the output is 11.
Yeah.
Suppose if it is a function instead of macro, suppose I have written a square function here. So then what will be the output?
Ma'am, what does the function do?
So when you call a function, so if you call a function here, so it will, your control will transfer, because the function is stored in a different location. Your main program is stored in a different location. So to execute the code of your function, your control should transfer to the definition of that function, execute all the instructions and come back. Okay. So if it is a function, so what it will do? Yeah.
Ma'am, in function, it will depend on the what value we are transferring to the function. Like if
Yeah.
we transfer a plus 1, then the result
First,
will be
a plus 1 gets simplified. So it will pass a single value to a function. That single value will be 6. Okay.
Yes, ma'am.
It will substitute 6 over there. So if it returns x into x means 6 into 6. So it will return 36. So if it is a function, your result will be 36. If it is a macro, your result is 11.
11. Okay.
I was saying it will be depend on what value we are passing. If we pass a plus 1, then
Like I am saying, you are passing a plus 1 to a function. So same,
No.
just instead of macro, I've written a function. I said the code is same.
Yeah.
Yes,
In macro,
ma'am.
ma'am, we use that BudMoss rule. In a function, we did not use any rule.
No. In all the cases, when you are simplifying your expression, you use operator precedence and associativity only. So there is no difference. But when your function receives a single value, so first it will evaluate the expression here itself. Here itself, it will evaluate this value.
Okay.
So that evaluated value, it will pass it to the function. Okay, whereas in this case, your control is not transferring. Just this whole code is replaced by x into x.
So
Okay.
yeah, in function,
So
it
the
will.
x value is a plus 1. Simply, it will pass the x value. X value is a plus 1. It will substitute, wherever there is x, it will substitute a plus 1.
Yeah, a plus
This,
1 we
this is
got 6.
replaced. This
So
is
it will.
replaced here.
Yeah. Like we got a plus 1 is 6. So it will just put the 6 at the place of the x.
Yeah. So if it won't simplify. It won't simplify, just substitute.
Okay.
Whereas in case of function, first it will simplify that simplified value will be passed to the function. So that in case of function, so this x value will become 6. So by the time it passed to the function itself, it will simplify and pass. So this will be 6. 6 into 6 will be 36. So
Yes.
it will return 36 here. That 36 is stored in this result.
Okay.
Next, what will be the output of the following C program? So A, B, two variables are defined with some value. And here we are using a conditional operator. So this question mark and colon is nothing but a conditional operator. So how the conditional operator will work in C language? So it will be like this. Expression 1, question mark, expression 2, colon, expression 3. So first it will evaluate expression 1. If the expression 1 is true, then your answer will be expression 2. If expression 1 is false, your answer will be expression 3. So if it is true, it will return the value after the question mark. If it is false, it will return the value after the colon.
Yeah, last value.
Yeah. So whether it is true or not, it depends on if it is 0, false. If it is a non-zero value, it will be true. Okay. So here the expression 1 is given as A greater than B. So A greater than B means 5 greater. So A value is 5, B value is 10. 5 greater than
false.
10 is
False.
false. False means it will return the value after the colon. So that means it will return A minus
A
B.
minus B. It will return 5.
5 minus 10. So it will return minus 5.
Minus 5.
Minus 5. Yes,
Yeah.
yes, minus 5.
So your answer will be minus 5.
Yes.
Okay. Your answer is minus 5.
Minus 5. Yes.
Next. What will be the output of the following C program? See here. So the A value is taken as 5 and you are calling a function called test. So test function is called with A value as the parameter. So now your control from here, your control will goes to the test function and this A value is copied into this A and now A gets incremented by 10. So now A will become 15. 15. So then after this function is over, so after completion again, it will return back to the calling place. To this place, it will return back and then execute the next instruction. Then it is printing the value of A. So what value will be printed here?
15.
Oh, so this is the logic we have. So this is a function calling with the value. So here this function is called with the value of A.
So ma'am,
So
here we
when
did
you-
not use any loop. So
No,
how
we
it
are
will
not
be
using.
repeat itself? Like
It won't repeat itself.
first
There is
it is
no
5.
repetition here. There is no repetition here.
How
Okay,
it is recall itself?
it won't call itself. Only once, see here, test the name of the function we are mentioning and we are passing the parameter. So that function is called.
Okay.
Okay, with the a value. A value is 5. So this a, see here how it will go. It is called by value. This is called call by value, calling the function by value of the variable. So this a is different from this a, or you can see here there is a declaration for a, and here also there is a declaration for a. That means this a is different from this a. Something like there are two class students. Say suppose for example, I am teaching in two different branches. Say IT and CSC. So in the CSC, the roll number 5 is different. In IT, the roll number 5 is different. A student who is having roll number 5 is different in IT, and a student having roll number 5 is different in CSC. So here in the main function, this a equal to 5. So this a is different. So whenever you declare some variable, it will allocate the memory. So which memory? Say for example here, in the main, when I see the declaration of a, int a, so your compiler will allocate some memory to it. So let us think that it has allocated a memory location of 2000, and there 5 is stored in the 2000 location. So let us think that this is not exactly 2000, it might be some other address. So I am considering that the address is 2000. So at this 2000 location, it has stored 5. So now when you call the function test, so again we have a declaration here, int a. So that means it will allocate another memory location for a. Okay, so it will allocate again a memory location. Let us think that it has allocated a memory of 3000. So when you call this is called actual value, this is called formal value. The actual value is copied into the formal value. So this a value is copied into this a. So that means whatever I have at 2000 location, the same thing will be copied to 3000 location. So here also it will store when you call the function by value. So this is called actual parameter. When you are calling the function, the parameter which we pass is called the actual value. When you are defining your function, the parameter that you are using is formal argument, dummy argument, you can say. Okay. So when you call the function, this dummy argument is replaced by the actual argument. Okay. So this a value is copied into this memory location. So the same value is copied to this. Now what you are doing, you are changing the value of a in the function. So when it is in the function test, so if you change the a value, which memory location value gets changed? You are in a test. So what is the memory location of a for in the test? It is 3000. This is the memory
Yeah.
location where your a is stored. Okay. Now you are changing the a value. That means which memory location value gets changed?
Test value.
Yeah, test. That means 3000 memory location gets changed. So this will be added with 10. So this will become 15. Okay. So
Okay.
the value of 3000 memory location, the value stored at 3000 memory location will become changed. So it is changed to 15. As
Yes.
long as you are here, a means it will refer to this memory location only.
Okay.
Okay, as long as I was in CSC class, roll number 5 of CSC student only I will refer. If I say roll number 5, the CSC roll number 5 will be standing.
Okay.
So if I am in IT class, the roll number 5 is different in a different person. If I say 5 in IT class, so the different person will wake up. Okay. So as long as I am in the test function, if I refer A, that means it will refer to this memory location.
Yeah.
Okay. So the memory location 3000 memory location value gets updated to 15 because
15.
of this statement. So after completion of this, your control is transferred to the main. So again, it will call to the coming to the calling place. And so this statement now it gets executed. Now, where is your control now? It is in the main function. As long as it is in the main function, which memory location it will refer? A means which memory
2000.
Yes, 2000. So what is the value at 2000?
5.
5. So it will display 5. It won't display 15 because here I am in the main. I am referring the A value. So when I am in main, the A value is means it will refer to this memory location. So it will print 5 only. So it won't print 15. So because what is the reason is, so when you call a function by value, so this value, actual value is copied into formal value, and the memory allocated for this variable is different from this variable. So whatever the value that gets affected inside the function, it will not reflected in the calling place without returning. Okay, if you didn't return this value doesn't change. Even though you updated the value in function, that updated value, it cannot be reflected in the calling place when you call the function by value. Okay. So the old value only it will display. Okay. Suppose if you call the function by a reference instead of value, if you pass the address. Okay.
Like a test A. If we write a test A, so it will print 50.
Wait, I'll show that with the practical. So this is my program. So if I run, so the value of A is 5 only. So even though you have changed the value of A here, so that is not reflected. See here, I am displaying like this. So here, printf, before calling test, A equal to %D. So before calling the test function, I am displaying the A value.
We are printing the value of A before the test.
Yeah. So what will be the value of A now?
5.
5. Yeah. Now I am calling the test function. The same I am displaying after calling. After calling test, I am displaying the A value. Okay. So because I have called this function by value, these two doesn't have any effect. So before calling the same value, it will have. After calling also same value, it will have, because you have called the function by value. Okay.
Yes.
So inside this function also, let me display. Inside test, inside a test function, the A value is, I am displaying the A value. So what will be the inside A value now? Inside this function, what is the A value?
10. Okay.
15.
A plus 10. Okay, so it will be 15.
Yeah, 5 plus 10, 15. Okay.
Yes.
So if you run this, you can see before calling test a value is 5. Inside the test a value is 15. After the test a value is 5. That means whatever the change that you made inside the function, that change has not reflected in the main program. The meaning of this is, inside the test you have changed the a value. That changed a value is affected only in the function, but it has not reflected in the calling place. This main is the calling place. Okay.
Yes.
So if you, instead of this, if you pass a reference or the address of a, so we'll call like this test. Instead of passing the value of a, I am passing the address of a. Okay. So that means what happens? So when you pass the address, the receiving variable will be a pointer. Is it? Which variable will store the address of something? Some other variable? A pointer. Pointer will have the address of a variable. So the receiving one will be a pointer. So when you declare a pointer, will the system allocate the memory?
Yeah, ma'am. And but how can we show the address to that pointer? So which at which value it will show?
Yeah, I'll tell you. So if it is a declaration like this, int a, your system will automatically allocate the memory. Whereas if it sees the declaration like this, it won't allocate. For the pointer, system will not allocate the memory. Dynamically, we need to allocate the memory if required. The user has to allocate the memory if it requires using MALLOC function, memory allocation function. Okay. So,
Okay.
but so this A now, so now when you see int A equal to 5, so it will allocate the memory. Let it be 2000 location. There it will store 5. Now you are calling the test function with the address of A. Here it is receiving into a pointer. So in the here it won't allocate the memory. New memory will not be allocated. So whereas this A is also pointing to this same memory. The A inside your test function. So system will not allocate the memory to this A, which is a pointer. In this pointer, we are storing the address of A of the main. So this is like a pointer which is pointing to, this is a pointer pointing to this memory location only. So now with the help of pointer, so we can write this statement like this now. Star A is equal to star A plus 10. So that means 5 plus star A means memory of, at that memory, which value you have? 5. 5 plus 10, it will become 15. And inside the test, it will display the value as, because P is A is a pointer. To get the value at that pointer, we use another star.
Yes.
Okay. Now, so as long as in this function also it is referring to the same memory, so this value gets updated as 15, and it will display 15 over here. So when it come back to the main, so A means this memory only. In the main also A is referring to this memory only. So then it will retrieve this value when you display the A value. So you will get 15. After calling also you will get 15. Okay. So the same, like when you call the function by address, okay, call by value, call by reference, and we are calling this as call by reference. Reference means it will pass the address of the variable instead of value of the variable. So when you pass an address, the receiving variable will be a pointer. If you made any changes to that pointer inside the function, that change will automatically reflected in the calling place. You need not return it. It will directly reflect in the calling place. So after calling, you will get 15 here. See this. So before it is 5, inside
Yeah.
the function it is 15, after calling also it is 15.
Yeah.
That is the main difference between call by value and call by reference. When you call by value, if you made any changes to that value inside the function, that change will not be reflected in the calling place if you didn't return it. Okay. Suppose in the previous case, I have called like this. Suppose by value I have called. Now I have written like this, A equal to test of A. So this test function is returning an integer value. Okay. So if I write it like this, what happens? So instead of printing there, I am returning the A value. So in this case, so now I am passing by value. So this A is different. So at 3000 location, this gets modified and I'm returning A. This return value, the function is returning a value. That value, it will store it in this. So I am modifying the A value with the value of this function. Whatever the value that is returned by this function, with that value I am returning, I am modifying the A. So after calling, that modification will be reflected. Now if you run this program, before calling A value 5, after calling 15, after calling also it is inside function also 15, after calling also 15, because I have written that modification. I have written that modification. So that it is reflected here. So if I didn't return this modification, even then it should be reflected. Means whatever modification that you made inside the function should be reflected in the calling place, even though you didn't return it. That will be possible using only reference, call by reference. So you will pass the address. So receiving variable will be a pointer, and you are modifying the value of your variable using pointer. So inside the function, the pointer value, variable value is this. And even after, it will reflect, because call by reference means they will be referring to the same memory location. So the value at the same memory location gets modified, and that modified value will be reflected in all the places wherever you refer A. So this is called call by reference. That is the advantage of this is how many values you can return from a function in C language? At a particular instance, how many values how many values you can able to return from a function? Only a single value. Any C function can able to return only a single value. Okay. So
Yes.
if you want to return multiple values from a function, I have a scenario, something like I want to interchange two numbers, A, B, or any two numbers. I have written a function to interchange those two values. So in that case, A has changed, B also changed. That change I want to reflect in the calling place. So how many values gets changed there? More than one value. So two values changed, but I can't return both the changes. So in that case, the only way I can able to reflect that changed values in the calling place is by calling the swap function with the reference instead of value. Suppose if I call a swap function with the reference, so what happened? I will pass the address of A, address of B to the swap function. There it will interchange. That interchanged values will automatically reflect in the column. So to return multiple values from the function, the only way is using call by reference. Or another way is using global variable declaration. Instead of declaring A, B inside the functions, you can declare a global variable, so that if it is a global variable, wherever you change, that change will reflect in all the places. Okay. So how you can return multiple values from the function is either using a call by reference or global variable declaration. Otherwise, every C function can return only a single value. Okay, I think you got the concept. If you call a function by value, whatever changes you made to that variable inside the function, that will not reflect in the calling place. If you call the function by reference, whatever changes you made to that variable will be reflected automatically in the calling place without returning it.
Yeah. And ma'am, one thing I want to ask, why we write that main statement again? This is the function, that's why. Because in the simple program, we did not write that main again.
You have to, must and should, you have to write the main. Without main, C program will not run.
Yeah, like in like a basic programs like a hello world and other
Yeah,
calculation
whatever it
and
may be, always the C program execution will start and end with the main function.
main function. Yeah, we write in the
Yeah,
starting, but not in the last. But in writing, I see
yeah,
that.
you can write the subfunction either above the main function or below the main function, no problem.
Okay.
This definition you can also write either above the main or below the main, no problem.
Okay.
Okay, so because here the test function is called by value, even though you change the a value inside the test function, that will not reflect here. So you will get the output as 5 only. Okay, so answer is 5, not 15. Now see this. Same concept. So now we call the function with reference address by passing the
Yeah.
address.
So it will
So
be
the receiver is a
12, 15.
pointer and you are changing the pointer value of that variable. You are increasing it by 5. So here it is 10. So it will copy the, so this pointer is also pointing to the same memory as A. So you'll have 10 there. So with the help of pointer, you are incrementing it by 5. So 10 plus 5 will become 15.
15.
So, okay. So when you refer A here, it will refer to the same memory. So you'll get printed with 15. Because
Yes.
you are calling the function by reference, whatever change you made to that variable inside the function will also be reflected in the calling place. So A value will be 15 now. Okay. So that is same concept. In the above question, asked call by value. Function with call by value is called. So no change. The changes you made is not reflected in the output. Whereas here, the changes you made in the function is reflected here because you call the function by reference, passing the address. Next. A 32-bit integer. So this is 0x means hexadecimal integer. It is a hexadecimal integer. So 32-bit means each digit in hexadecimal will occupy 4 bits. So you will get 32 means how many? 18 to, 18 to 430. So 8 hexadecimal digits are defined here. Is stored in a memory starting at address 2000 on a little endian system. So little endian system means it will store the values from leftmost to the rightmost. Okay. So little endian means it will store. It will
Like
start
most
at a D.
significant bit
It
to
will
least
start at
significant.
most significant bit, and it will go to the least significant bit. Whereas if it is a big endian format, it will start at least significant bit and goes to the most significant bit.
Yeah.
So that means it is starting address is 2000 and little endian format means first at 2000 location, it will, at each memory location, we can store
It's
only 1
located.
byte of data. 1 byte of data. So that means DE. So DE is 4 bits, E is 4 bits, 4 plus 4, 8 bits. So DE is stored in 2000. In the next location, 2001 AD, 2002 BE, 2003 EF. So sorry, little endian means it will start at LSB, goes to MSB. So that means at 2000 it will store EF, 2001 BE, 2002 AD, 2003 DE. So this is correct. Okay, it will move from left to right. Little endian means. Little endian
Okay, ma'am,
means
that one is big Indian.
big endian means it will move from MSB to LSB. That is it. So this option A is a big endian. This option B is a little endian.
Yes.
So starting location will be this one, EF, BE, AD, DE. 1 byte it will store at each memory location. Next, what will be the output of the following C program? So we have declared an array of size 5 and the values stored are 1 to 5. So array of 0 will be 1, array of 1 will be 2, array of 2 will be 3, array of 3 will be 4, array of 4 will be 5. 0 to 4 indexing. 5 elements means the elements are indexed from 0 to 4. So we have declared one pointer. It is pointing to this array. Array name itself is the starting address. That means the value 1 is pointed by PTR. The address of 1 is pointed by PTR. Now what you are doing? PTR equal to PTR plus 2. So what happened here? See here. Suppose, so array means it will store contiguously. Say for example, think that array is an integer type. Each integer is taking 4 bytes of memory. Think that. Okay. So at 2000 location, the value 1 will be stored. Now second value. So because integer 4 bytes. So 2000, 2001, 2002, 2003. All these 4 memory locations are for 1 only. First value. So next value will be stored at 2004. So it will store 2. Next value will be stored at 2008. 3. So next value will be stored at 2000. Think that 10. So 4. 2010 it will store 4.
It will be 12.
Yeah, sorry, 12. So 2016, actually it is not 12, B actually. So in the hexadecimal, so for our easy understanding, I am saying like this. So 2000, so each memory, each value will occupy 4 bytes. So this is the way, contiguously it will store the values in an array. So these are the memory locations. Now your pointer PTR is at here. This only your PTR is pointing. Same memory location. So now what you are doing? You are incrementing the PTR by 2. What happens when you increment or decrement a pointer when it is pointing to an array? So now your PTR is pointing to an array. Okay. So when you increase or decrease, it will be incremented or decremented by the size of the element in that array, not by 1. Generally, what happens when you say plus, what happens? It will be incremented by one unit. But how much it gets incremented is, suppose if I say PTR equal to PTR plus 1, if I say, that is incremented by the size of the element at that array, where PTR is an address pointer. So that means what is the size of the element that is stored in this array? Integer we are taking the size as 4 bytes. So when you say, when you increment the pointer by 1, it will be incremented by 4 bytes. So now, suppose if your PTR is at 2000 location, if you say PTR plus 1, what is the location of PTR now? It will be 2004. Have you got it? If your PTR is at a location
Yes, ma'am.
2000, so if you say PTR equal PTR plus 1, it will be a pointer. When you increase or decrease a pointer, or when you perform some arithmetic operation on pointer, it is incremented or decremented by the value, size of the value that is stored at that address. So what is the size of the value that is stored in this address? Size of int. So we have considered size of int as 4. So it is incremented or decremented by 4. So 2000 plus 4, it will be 2004. So now your PTR is pointing to this location when you increment once. Now how many times it gets incremented now? 2 times. PTR equal to PTR plus 2. So that means 2 locations it has incremented. So that means it is pointing to now 2008. Okay. So when you increase 1 time, it is incremented by 4. When you increase 2 times, 2 plus 2 means it will be incremented by second element. So first increment, it will come to this. For the second increment, it will come to this location. So now your PTR is here, and you are displaying the value at that location. Star PTR means value at the, what is the value at this location? 3. So it will display 3. Have you got it? So initially your PTR is at 1. The address of 1 it is pointing. When you increase it 1 time, it will point to 2. This location, address of this. When you increase 2 times, it will pointing to the address of this. When you increase 3 times, it will pointing to. So like that, when you increase or decrease a pointer, when the pointer is pointing to an array, it will go to the next element. Okay, remember that. It will go to the next element. So address of next element. So now ARR means starting element address is there in PTR. When you increase it for 2 times, it is pointed by the address of the next second element. So second 2 times. So from 1, it will increment to 2, from 2, it will increment to 3. So it is now pointing to the address of this element, second element. 0th element, first element, second element. So value at that address is now 3. So it will, the output of this will be 3. Have you got it? Pointer arithmetics concept we have used. Next, what will be the output of the following code snippet? So what did we do here? Union. We have defined a union. The name of the union is value, and it contains 2 variables, 2 members. First member is an integer, second member is a float. Name of the first member is I, the second member name is F. There are 2 members inside the union. So what is the property of the union? It will allocate memory to only 1 element. Like at a time, only 1 element will be active, and always it will allocate the memory to the largest element. So that means what is the size of this union variable? It will be 4, because the largest element here is a float. Float means 4 bytes. So for the union variable, the size is 4 bytes. Largest value. So how many union variables we have declared here? Array. So two elements. Array of size 2. That means array of 0, array of 1. So 2 union variables are created here. First variable is array of 0. Second variable is array of 1. Now array of 0 is pointing to the I value. So array of 0 dot I value is 42. Suppose if I refer array of 0 dot F value, you will get a garbage, because in union only one member will be active at a time. So because I is assigned 42, so f if you refer f, you will get a garbage value. So here at array of 1, so for the second union variable, we have assigned the f value. So f value, if you refer, it will get the correct one. If you refer the I value of the second variable, you will get a garbage. So here what we are doing, array of 0 dot I value we are referring, array of 1 dot f value we are referring. So those are the values that you have defined. So your output will be 42 and 3.14. Array of 0 of I means you will get 42. Array of 1 dot f means you will get 3.14. Suppose if I, instead of this, I have displayed here array of 0 dot f, then you will get, here you will get 42, but here you will get garbage value. Okay. So here you are referring two different variable values. So both will be displayed correctly only. So the array of 0 is 42, array of 1 will be 3.14.
I think your voice is lagging little.
Yeah. Wait.
And
So
there will be how many questions?
around 25 to 26. Like,
Yeah.
let me log out and log in quickly, so that this logging problem will be. Stay back, I'll log out and log in. Hello.
Yeah, ma'am, audible.
Okay. So is the screen visible?
Yes, ma'am.
Okay.
But your voice is low now.
My voice is low.
Yeah, now it is better.
Okay. So here we are referring to the two different union variables. So array of 0, I am referring array of 0 dot I. Array of 1 value, I am referring array of 1 dot f. So both are defined correctly. So you will get the output as 42 3.14. So let us see the variations here. We'll run and I'll show you the variations.
And so in next week class also we will also solve like other paper, no?
Yeah, yes. By the next week, you will be released with mock end term.
Okay, okay, okay.
So in my next
will solve that.
class, I will solve the mock end term. Whereas the other classes of this is Saturday and next Tuesday, you have the sessions. No, in those sessions, they will solve a different paper.
Okay, ma'am. Okay, ma'am.
So if I run, so I'll get correct values 42 3.14. So instead of this, if I write here, instead of 1, I am writing f. So it means from the same union variable, I am axing both the members, both the I member as well as f member. But you know the union property that only one member will be active at a time. So if you that means only one memory location will be there, the same memory location will be shared by both. So because I have assigned the I value here, so the f value, it will take the garbage. See here, I value is 42, whereas when I refer f value, it has given a wrong answer. Okay, whereas suppose if I refer both 1, so that means second variable, union variable, I am referring both I and f. So for the second variable, I have assigned the f value. That means for I value, I should get some garbage value, garbage or a wrong value. See here, the f value is displayed correctly, whereas for the I value, it has displayed some garbage. Okay, because union means only one member will be active at a time. Okay, so that active member will be the one which we have assigned recently. Suppose think that after this I have assigned again ARR of 0 dot f equal to 5.4. Suppose I have assigned like this. So initially I have assigned I value as 42. So at the end I have assigned f value as 5.4. So that means the same memory will be overwritten. I value location is overwritten by f. So this will be erased and the active member that gets displayed when I refer to the array of 0 is f, not I. Okay, even though I have assigned both, the recently assigned one will be the active one. So the recently assigned value is f. So you will get the correct answer for f, garbage answer for I. See here.
What thing we get in a garbage map? Like we get 0 or any.
No, like it whatever that is there in the contiguous 4 bytes, that value it will convert into integer. It will try to. Like you can't guess,
Random.
Okay.
can't guess.
Okay.
Okay. The next one. What is the primary difference between the file modes W and A in C? So W means it will create a new file by overwriting the existing one if it exists. Otherwise, it will create a new one. So that means write will write the data from the beginning of the file. Whereas if you open the file in append mode, so it will write the data at the end of the file. Okay.
Yeah.
W will write at the beginning of the file, whereas A will write at the end. Even this first option is also correct for me. I think you have a something like this. You have to select most appropriate one. Okay. So because it is MCQ, suppose in case if it is MSQ, you can select both append data, but W first clear the file. So it will clear the file and then add it. Whereas append will not clear, it will add at the end. Okay. So, but this is more appropriate than in the meaning than this. So this is correct. W writes at the beginning, whereas A writes at the end. The remaining options are wrong. Whereas first option is also looking good for me. Both append the data. That append in the sense they will write the data, but W first clear the file, because if file exists, it will overwrite. No, so that you can consider like a clear. So whereas meaning wise same, but the sentence is not correct. Okay, both will write
Yes.
the data. Instead of append, we can say both write the data, but W first clear the file. Okay,
Yeah.
append is wrong maybe. Mm.
It will make a new file or create clear the thing written in the file
Overwrite.
present.
It will overwrite the file. Mm.
Yeah.
Which of the following best describes a macro in C? Macro means a block of code replaced during the pre-processing phase. I told you in previously one example, x star x. So what it is doing,
Yeah.
if it is a macro, it will replace the code. Whereas if it is a function, it will control will transfer to the code definition of the code. Okay.
Yes.
So a block of code replaced during pre-processing phase. So when it gets replaced is when you compile, first it will compile, link, and then run. So when you link, when you are in the linking phase, that is pre-processing phase, that replacement will happen, not at runtime. Okay, in the pre-processing, when you are linking the linker, your linker will, your compiler will first compile it, and after that it will, your linker will link all the modules, then it will start executing it. So in the pre-processing phase, the code will be replaced. It will not replace at runtime. It will not store in the stack. In case of function call, it will store in the stack memory. A predefined function of C standard, no. So among these two, it will replace the code during the pre-processing phase, not at runtime. Okay.
Yes.
Next question. Which of the following statements about conditional compilation is false? Conditional compilation means like
Yeah. I think your screen is lagging only for me or what?
is
No,
it
ma'am. I think it's perfect. Like you are currently on
Maybe.
tab.
Yeah, I am
No,
in.
ma'am, it's perfect. I think you are in the taskbar
Yeah.
currently.
Yes. 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 I am in the taskbar. Maybe I think you have a slow internet connection. Maybe.
Okay.
Okay. So, here, conditional compilation means like where, like when you are doing a pre-processing compiling, we use if def, if not def, if all these are pre-processor directives only. Hash if def, hash elif, hash end if, all these are the pre-processor directives only. So when it is doing a conditional compilation, it may include some code or it may exclude some part of the code. That means it will add a new code to that, or it can remove some of the code from that. So your code will change. Inclusions and exclusions will be done. So this is correct statement only, first one. Okay. So hash elif is used for multiple conditions. Yes. Suppose if the first condition is false, we use hash elif. Second condition. Again, if that is also false, we will write again else if. Like that, you can write it for elif for multiple conditions. Okay. So this is also correct. Hash end if must end every conditional compilation block. Yes, wherever you use if, hash if, that if should be ended with hash end if. Okay. So this is also correct. Whereas if def can be used without defining the macro. So if the macro is defined first, then only we can write hash if def of that macro name. So this if def can be used when the macro is defined. Without defining the macro, you can't use hash if def. So this is false. Second option is false. Whereas all other options are correct only. Next, which of the following statements about pointers is are true? A pointer can be incremented to point to the next memory location of its type. Yes, when you increment the pointer, what happens? It will increment to the memory location based on its type. If it is an integer, it will increment by 2 bytes. If it is a float, it may increment by 4 bytes. If it is a double, it may increment by 8 bytes. Like that, based on its type. Dereferencing a pointer gives the value stored in a memory address that it holds. So dereferencing means on pointer, if you use a star, so value at that pointer, we say value at that pointer, that is called dereferencing operator. That star is called dereferencing. So it is used to give the value stored at a memory location. So these two are true in case of pointer. A pointer variable cannot be reassigned after initialization. Yes, you can reassign it. You can reassign it. So this is false. Dereferencing pointer gives the memory address it holds. No, dereferencing pointer will give you the value of at that address. So these two are wrong, whereas these two are true. Which of the following statement is true about arrays in C? So C arrays are 0 indexed. So indexing in an array will always start from 0. The name of the array points to its first element of memory allocated for the array. So array name itself is a pointer to the first element. Array elements are stored in contiguous memory locations. Okay. So if the first element is at 2000 location, Second element will be contiguous. Suppose if the value is an integer, if integer takes 4 bytes, next value will be 2004, next value will be 2008, next value will be 2012, like that. Contiguously, it will store based on its data type. So, whereas array can hold elements of different data types, that is wrong. Always an array can store all the elements of the array are of same type, not a different type. All must be integers, or all must be strings, or all must be characters, all must be float values. Like that, all the elements of your array are of same type. They are not different types. So this is wrong. Whereas all the others are correct. So this is multi-select question. When multi-select question, there will be more than one answer will be corrected. Correct. So you have to choose according to that. If it is an MCQ question, only one answer is correct. If it is a multi-select question, MSQ, there might be more than one answer is correct in the given question. Next, which of the following statement is true about structures in C? So structure will store different, all the members might be of different data types. In an array, all the elements are of same data type, whereas in a structure, you can have each member can be a different data type. And how to access the structure members? You can access the structure members using dot operator. So the last is also correct. So what is the size of the structure? Is nothing but the sum of the sizes of all the elements in the structure is the size of the structure. Okay. Whereas this size of the structure, always the size of its largest member is given, so which is wrong. So this is true for union. The size of union is always the size of its largest member, but the size of the structure is sum of the sizes of all the members of that structure. Structure cannot be nested within another structure. Yes, you can nest it. Okay. Say suppose if you are writing a student information, roll number, name of the student, date of birth, like that here. So the date of birth can be another structure, date structure, which consists of day, month, and year. So inside one structure, you can define another structure. Nested structures are allowed. So, but here it is not allowed is given. So this is wrong. So the correct answer is structure can contain members of different data types, and member of structure can be accessed using dot operator. Even you can use arrow if it is a pointer. If it is a normal member, we use dot. Next, consider the below C program. What will be the output of the program? So A value is 5, B value is 10, star PTR A. So A is address of A is pointed by PTR A, address of B is stored in PTR B. Now what we are doing, we are changing the PTR A value, star PTR A equal to plus equal to star PTR B. That means this statement is nothing but PTR A equal to PTR A plus PTR B. So PTR A is 5. So 5 plus 10. PTR B value is 10. So 5 plus 10. So it will be 15. So now PTR A value, address of, at this address, you will have 15. 5 plus 10, 15 will be stored. So if you now print the A value, so A means A value is pointed by the PTR A. So if you can change the A value using A or using PTR A, because both are same addresses. Both are pointing to the same memory location. So you can change the value of that memory location with the help of PTR A or with the help of A. So we have changed PTR A value. So that will also reflect the A value. So if you print the A value, A will be 15 now. Okay.
How can we get that PTR A is equals to 15?
See here. So first what we did, int A equal to 5. So whenever your compiler sees this, it will allocate some memory to A. So let us think that 2000 is the memory location allocated to A. At that memory, it has stored 5. It has stored 5.
Yes.
So now it sees the declaration of B equal to 10. So it will allocate a different location. Say for example, 3000 location. At that location, it has stored 10. Okay. Now what we said, we have declared 2 pointers. So this pointer A is pointing to the address of A. So the same location is also be pointed by PTR A. So the same memory location is also be pointed by PTR B. Okay, PTR B is storing the address of B. That means in the PTR A you have 2000. In PTR B you have 3000. Same memory locations are pointed by PTR A and PTR. So A is pointing to A, address of A, B is pointing to the address of B. Now what we are doing, we are changing the PTR value at the PTR A. What is the value at PTR A? 5.
5.
So this value we are changing. How we are changing? Plus equal to means the same value plus the value at PTR B memory. So 5 plus 10. So this is changing as, so that change will be reflected here. 5 plus
Okay.
10, which is equal to
So,
15.
so change
So
occurs here like a plus equals to.
yeah. So at
Okay.
this location, you are changing the memory location value to 15 at this location.
Yeah.
Now after that, it is printing the A value. So A means which memory location it will refer? 2000. So at
Yes.
2000, what is the value now we have? 15.
50.
So it will display 15 here. Okay. So the value of A is 15. So this is a NAT question. NAT means numerical value, numeric value. So that
Yes.
means fill in the blank. You have to fill that with some numerical value. So what is the numerical value that fills here is 15.
15.
Next. So this is an enumerated code, enumerated data type, enum. So consider the following code. Enum value, enum variable name is color. So color values are defined: yellow, blue, green, yellow, orange, like that. So these are the possible values for color. The 5 possible values will be there. Color can be red, color value can be blue, color value can be green, color value can be yellow, color value can be orange. Okay. So if you didn't specify any integer like this, 3, 7, so it will let me run this and then show you the variations. So first let me discuss this and then I'll show you the variations. So color value, so when you define an enumerated data type, the value of the enumerated variable can be like easily you can refer with these names instead of value. But
Yes.
internally, it will be assigned an integer value starting from 0. So this is 0, this is 1, this is 2, this is 3, this is 4, like that it will assign. Okay. So if you give the default value, it will start from there. So I have assigned red equal to 3. That means this red is having the 3. The next value will be continued from there. So that means blue will be 4, blue will be 4, green will be 5 actually, but again we reassign the green value. So that is 7. So the next value will be 8, 9. Orange will be 9. Okay. So if you assign, the next value continue from there. If you didn't assign, it will assign from 0. Okay. So here, so red value is 3, blue value will be 4, green value is 7, which is assigned, yellow value will be 8, orange value will be 9. Okay. Have you got it? So now
How did we know that yellow and orange value?
it will continue from the previous. So
Okay.
if this is 7, the next value will be incremented by 1.
So enum means that because of enum that happens.
Because of
Enum.
enum, enumerated data.
Yes.
Yeah. So
Okay.
it has displayed the orange value. It has displayed orange. What is the orange value now?
9.
9.
9. So it will display 9.
Yes.
Okay. The answer is 9. Okay. So let me run and show you the variations. Okay. So let us think that I have not assigned this. So in this case, what will be the orange value?
3, 4, 5, 6, 7. 7.
7. So orange value is 7.
Yes.
Suppose if I didn't assign this, then what is the orange value?
5.
4. So this is 0, 1, 2,
Okay.
3, 4. Orange value. So it will start from index 0 by default.
Okay. If there is no number of assigned, there
Yeah,
is no number.
it will start from there. Suppose
0.
if
Okay.
I assign 5 here, so this will be 6, 7, 8, this will be 9,
9.
like that.
Yes.
Okay. Even I can assign a middle values also. So I can say if I have assigned this as a 20, then this will be 21, this will be 22.
And what is the blue? What we can expect?
6.
Okay.
This is 5. The next one will be 6.
Okay.
Okay, like that. Either you can refer to the numerical value of it, or you can refer to the enumerated value of it. That means you can call it as either green, blue, red, like that, or you can call it as 0, 1, 2, 3 also.
Okay. So, ma'am, what type of program we need the enum?
Like for easy reference, we use enum. Like like here, generally what we expect the color value, we won't expect the color value as 1, 2, 3. So in our general language, we say that the color can be red, or color can be blue, or color can be green, like that. So you can, using enum, you can refer your variable values when compared to your real world, how it will be. Okay, in the easy sense, you can able to refer it. But internally, your computer will be considered as this is the 0th value, first value, second value, like that.
Okay.
In the next, what is the value of the array 2, 1 in the following array declaration? So here 2-dimensional array is initialized. There are 3 rows and 3 columns. So this is the first row, this is the second row, and this is the third row. So 1, 2, 3 are the first row, 4, 5, 6 is the second row, 7, 8, 9 is the third row. Okay. So we are asked to display what is the value of array second row, first column.
First column. Yeah.
So this is the 0th row, first row, second row. That means in this row, first column. So this is 7 is the 0th column.
Here also
8
start
is the
from
first.
0.
Always the array will start from 0.
Okay.
So 0th row, first row, second row. From this row, you are asked the first column. So this is 7 is the 0th column, 8 is the first column, 9 is the second column. So first column means 8. So
Okay.
array of 2, 1 means it will display 8.
Yes.
Okay. Next, given a file handling operation in C, so you have declared a file pointer and you have opened the data.txt file in read mode. So that means this file exists in your directory and it may contain some data. So you are opening that in read mode and count value is 0. So what you are doing, fgetc will read a character from this file. So data from data.txt, it will read one character is not equal to EOF. So that means it will read
End of the
character
file.
by character till the end of the file. And each time what it is doing, it is incrementing the counter. That means it is counting the number of characters in this file. It is counting. This counter is a counter. This is incremented how many characters you have in this file. So
Yes.
when it reaches to the end of the file, you are closing it. So what value will the count hold after compilation of while loop if the file data.txt contains the string hello world? Suppose hello world is stored in the file data. So first when it reads the first character means H. 1,
H E
2, 3, 4, 5, even
and
space will be
space.
considered.
Yes.
6, 7, 8, 9, 10, 11. So by the time it reaches to the end of the file, it is incremented by 11 times. When it comes to the after ready, it will go to the end of the file. So the count value will be 11. So okay,
Yes.
the count
And
value
ma'am,
will,
what is the meaning of question mark sign in that programs?
yeah, question mark means what? Like generally when a question start with what, at the end you will have question mark. This belongs to the question mark, not the data of your file.
No, no. Like in a previous program, we see that uh, precedence wise, there we use a question mark, then colon.
Yeah, that is conditional operator.
Yeah, conditional operator.
Mm.
So what is the use of that question mark there?
And that is syntax operator. Conditional operator
Okay.
in the C is question mark and colon.
So it is predefined that we had to
Predefined.
use first
Yeah.
question mark. Yeah.
Like if
Then
the
colon.
condition is true, immediately you will have a question mark. After the question mark, whatever you have, that is the result if the first condition is true. If it is false, it will return the value after the colon. That is a syntax.
Yes.
Colon question mark is a syntax.
It's same like if else.
Yeah, it's same like simple if else. Okay, so those are the questions. Okay, so
Yes, ma'am.
almost
Thank you.
there are 25 questions only. Yeah, because the first question is just guidelines. So there are 25 questions in the test. Almost nearly it will be like 25, 20 based on the difficulty of the question. The marks can be 4 or a 6. Okay, like that the marks might vary, because I think here all the questions are carrying same marks, 4 into 2500. Okay, it may not be all the 4. Sometimes it may vary. If you have a
Yeah.
somewhat difficult question, it may be more marks. When it is a theoretical type of question, you may get less.
In numeric questions, we get 4 marks. Like
Yeah, more marks in the numeric questions because it is a fill in the blank.
yeah.
And the coding questions also you might have more marks.
Yes.
So like that, next week also we will discuss one of the sample questions, like either it can be a mock, or if mock is discussed by some other staff, then I'll discuss another question paper.
Yeah. Okay, ma'am.
So, ma'am, will you send this PDF anywhere?
Like you
Or
can
ma'am-
download it from ACE grade.
Okay, ma'am. So, ma'am, is it a official website? Actually, sometimes I got confused. Like, is it an official website or
No,
unofficial?
unofficial.
Okay, ma'am.
ACE grade, you can download it from ACE grade. Okay, acegrade.in. Is it like that?
Yes, ma'am. Actually, I got to know about this, but in the community section somewhere it asks you to log in from student email. That's why I thought
No
like
need,
it just
no need of
no.
login. You can.
Yeah, yes, ma'am. I will not log in. I just thought like it's an spammy unofficial mail because
No.
why if a student want to give, it will give in the dashboard. That's why.
Okay, you can download it without login. You can go to the previous question papers, and then you can download it.
Okay, ma'am. Thank you.
Okay, ma'am. So I'm ending this session.
Yeah. Thank you, ma'am.
Then,
Thank you, ma'am.
okay. Good night.